Okay, welcome to the second half of this lesson. We're going to talk about now proportional parts of parallel lines. And if we have a condition such as this, where we have got three parallel lines, in fact, if you've got three or more parallel lines intersecting two or more transversals, then they're going to cut off these transversals into proportional segments. In other words, if these three lines are parallel, then Hj over Jl will equal Ik over Km. And if you go out infinitely in both directions and there are other transversals, you're going to see those same proportions. Hj over Jl will equal Ik over Km. Now an equivalent proportion would be Hj over Ik equals Jl over Km. You might see something like that. So why is this true? Proportional parts of parallel lines. I'll give you a hint. What do you see there? Instead of two similar triangles, like we talked about in the first part of the lesson, we really have three similar triangles here, don't we? When you extend these out, we've got a triangle here that's similar to this triangle, which is similar to this triangle, and so you can see why these proportions are going to be valid. Let's try a couple of examples. Here we've got this figure. We've got Larch, Maple, and Nuthatch streets that are all parallel. I'm going to go ahead and mark that. If these streets are parallel, let's mark it. The figure shows the distances in between city blocks. Could we find X? Okay. Well, if these lines are parallel, then these parts are going to have to be, these transversals are going to have to be cut off proportionally by these parallel lines. In other words, 26 over 13 should equal x over 16. X over 16. Now, you can do cross products here, but there might be a shortcut. I mean, you can go ahead and do cross products. You can solve these any way you want, as long as you use the properties of algebra, right? 26 times 16, so is 416 equals 13x. That's my other cross. 26 times 16 equals 13 times x. And we'll divide both sides by 13. And then I'll show you the shortcut. You get x equals 32. Okay, so what's the shortcut here? Recognizing that the ratio of these two is 2 to 1. 26 over 13 is 2 over 1 if you were to put that in lowest terms. So if this block is twice as long as that block, this block's going to have to be twice as long as that block, which is 32. Okay, so that's a little shortcut you can use. Let's try another one of these. Here, Broad, Davis, and Main streets are all parallel. Broad, Davis, and Main. Okay, let's mark those. And we've got these distances between city blocks. Could we find x here? Okay, now you can set up your proportion if you want. 24 over 8, do you want to do that? 24 over 8 should equal 15 over x. Okay. You might have also said, hold on, could I do 24 over 15? 24 over 15 equals 8 over x. Yeah, you could do that one too. You're going to end up with the same cross products. Now, you might want to reduce that to lowest terms. 24 over 8 is what? 3 over 1 equals 15 over x. Okay, you can do that. You can also say, hold on, this block's 3 times as long as that block. I bet this block will be 3 times as long as that block. If this is 3 times x, then x must be 5. And you can confirm that with your cross products. 3x will equal 15. Divide both sides by 3, and we get x equals 5. Okay, and even if you didn't reduce it to lowest terms, you're going to get the same result. 24x equals 15 times 8 is going to give me 120. When I divide both sides by 24, I'm going to get x equals 5 again. These are really beautiful problems because there's lots of different ways to arrive at the same correct answer. Let's try another one. Oh, new concept. Congruent parts of parallel lines. So this is kind of an extension of our last theorem that we talked about. If we've got 3 or more parallel lines, and if they are cutting off segments such that they're congruent to one another, then guess what? They will cut off every transversal into congruent segments. Okay? If 3 or more parallel lines cut off congruent segments on one transversal, then they're going to cut off congruent segments on every transversal. And I can extend these out infinitely. And no matter what angle my transversals come in at, I know they're going to be cutting those transversals into congruent segments. Okay? If these two are congruent, then every single transversal that crosses these parallel lines is going to be cut into congruent segments. If this is true, I actually know that these parallel lines must be equidistant. They must have, each of these lines is equidistant from the center line. All right, let's try some examples. Here, could we find x and y? Well, I get 3x minus 7 equals x plus 5. Hopefully this is jumping out at you because of these congruence marks. 3x minus 7 equals x plus 5. That's not too bad. We can solve that for x. I'll subtract x from both sides. I get 2x minus 7 equals 5. I'll add 7 to both sides. I get 2x equals 12. Divide both sides by 2. And we get x equals 6. Okay, good. How do I find y, though? I don't know. I don't know why. Now, you don't have to plug x back in here and set up a proportion in order to solve y. I know that if these two segments are congruent, if this transversal is cut into two congruent segments, guess what these parallel lines are also doing to this transversal? They're cutting it into congruent segments as well. So I can now say, aha, 9y minus 2, in spite of the fact that they didn't tell me these segments are congruent, I can conclude that 9y minus 2 must equal 6y plus 4. I can solve that for y. I'll subtract 6y from both sides. I can add 2 to both sides at the same time. I get 3y equals 6. We'll divide both sides by 3. And we get y equals 2. Good. Okay. I think I have one more example. Let's take a look at this last guy here, looking to find a and b. Okay. How about a? A looks good because these two segments are congruent. These two expressions must be equal to one another. So I can grab those. 4a minus 5 must equal 3a plus 6. I'll subtract 3a from both sides. Add 5 to both sides at the same time. And I get a equals 11. Good. But how do I find b? They didn't tell me these segments are congruent. Well, let's look closely here. These lines are parallel. And if they cut off congruent segments on this transversal, they must be cutting off congruent segments on this transversal as well. So I can conclude that 3b must equal 5/3 b plus 2. Okay, how do I solve that for b? Well, I'm going to call this actually 9/3 b. Why did I do that? Because I know I'm going to be subtracting 5/3 b, and to add and subtract fractions, I have to have common denominators. 3 is the same as 9/3. So I'll subtract 5/3 b from both sides, and I get 4/3 b equals 2. I can divide both sides by 4/3, which is the same as multiplying both sides by the reciprocal 3/4. Those conveniently delete each other. I get b equals 2 times 3 is 6/4, which is 3/2. 3/2 or 1 1/2, however you want to slice it. All right, that is my lesson on parallel lines and proportional parts. Hope you guys found it helpful. Good luck on the homework.